A. Dina invests $600 for 5 years at a rate of 2% per year compound interest. Calculate the value of this investment at the end of 5 years. So we are dealing with compound interest, starting with $600 and 2% per year. So compound interest is interest added on. So it's like increasing $600 by 2% every year for 5 years. So we have 600 multiplied by 100, add on 200, and for 5 years, so we do that 5 times. So it will be to the power of 5. If we rewrite 100% and 2% as decimals, that's 1 plus 0.02. So we can find the value of the investment after 5 years by doing $600 multiplied by 1.02 to the power of 5. And that gives 662.44848 and so on dollars. So for money only goes to 2 decimal places. So for money, answer to 2 decimal places. So our answer would be 662.45 in this case. For most of your answers, when you have to round it, you round to 3 significant figures, but for money, round to 2 decimal places. B. The value of a gold ring increases exponentially at a rate of 5% per year. The value is now $882. 1. Calculate the value of the ring 2 years ago. So this is like compound interest. Increases exponentially is just like compound interest. And we want to find the original value. We want to find the value of the ring 2 years ago. So if we let that equals x, so x was increased at a rate of 5% per year, so 100%, add on another 5% for 2 years, so that's to the power of 2, because we're working like compound interest. And we know that this equals the value now, which is 882. So we can set this up and solve for x by rewriting the percentage as decimals. So we know that x multiplied by 1.05 to the power of 2 equals 882, and we can use this to solve for x by dividing both sides by 1.05 to the power of 2. So x equals 882 divided by 1.05 to the power of 2, x equals 800. So the original price of the ring was $800. 2. Find the number of complete years it takes for the ring's value of 882 to increase to a value greater than $1,100. So we start with $882. We know that it increases exponentially 5% per year. So this means that with 882, every year that goes by, it goes up by 5%. And we start with $882. So to increase something by 5%, we multiply it by 1.05 in terms of decimals. And increasing exponentially is like compound interest. So we would do 1.5 to the power of the number of years. And we want to find out when this is bigger than 1,100. So this is an inequality. When we have an inequality, we can actually just treat it like an equal sign. So if I change that to an equal sign, we want to find how many years it takes for this to equal 1,100. And right now at IGCSE level, it's impossible for you to solve the problem or make years the subject of the formula to find the value. So what you can do is actually trial and error. For example, let's take a guess first. So let's guess maybe it's 10. So you would type 882 multiplied by 1.05 to the power of 10. That is 1,436. So that's too much. So I want to try something that's less than 10. Maybe I should try 5. Okay, so if I do 882 multiplied by 1 to the power of 5 to the power of 5, that equals 1,125.6. So that's bigger than 1,100 already. So I'm pretty close. So let's try 4 years. So that's 882 multiplied by 1.05 to the power of 4. And when it's to the power of 4, it equals 1,072, which is less than 1,100. So the value exceeds 1,100 between 4 years and 5 years. This means it takes a complete 5 years for the value to be bigger than 1,100. So in terms of working out, when you do trial and error, what you can do is show your trial and error. So I can show that 882 multiplied by 1.05 to the power of 4 equals 1,072.0765 and so on. Then 882 multiplied by 1.05 to the power of 5 equals 1,125.680. Therefore, somewhere between there, it crossed the line, right? It was greater than 1,100. Therefore, the number of years it took would be 5 years.